Okay, hi everybody. I wanted to give you another video here talking about a problem that hasn't shown up a lot in class or in the review package here. Okay, car A leaves the intersection traveling north at 80 kilometers an hour at the same time as car B, 100 kilometers east of the intersection, starts approaching the intersection at 60 kilometers an hour. What is the minimum distance between the cars? Okay, now to understand this problem here, we gotta draw this thing out first. And so what's happening here is we've got car A at the intersection, okay, and it is moving 80 kilometers an hour, okay, 80 kilometers per hour. Now at the same time, over here, we have got car B, and it is moving, okay, 60 kilometers an hour, but it starts with an initial displacement here of 100 kilometers to the east here. Now, in terms of how we're going to identify plus and minus, I think what we're going to do here is a very natural thing. We're going to make north positive, south negative. We're going to make east positive and west negative. So to make this all work out here, to understand what's going on here, we want the distance between those cars to be a minimum. That's going to be the d is the distance between them. And so this becomes a Pythagorean theorem problem. Now, we're going to do everything, though, in terms of time. Okay, now when you do these minimization problems, it's got to be time that you're minimizing. So d squared is going to be, well, the distance that A travels along in any given time there is going to be 80 times t squared plus the distance that B is from that intersection will be 100 kilometers minus 60t all squared. Okay, now I could expand that out. I could when I take the derivative, because now I've got everything in terms of one variable here, t, but actually what I'm going to do here is take the derivative implicitly. So it'll be 2d d primed will equal 2 80t times 80 plus 2 100 minus 60t times negative 60. Okay, notice that the 2's all cancel. And what I'm going to do here is I'm going to just isolate the d primed here. And when I multiply that out here, I'm going to get 6,400t. What I got here? Minus 6,000 plus 3,600t. And that's all going to be over d. Okay. A little bit of simplifying here, we're going to get that d primed is going to equal 10,000t minus 6,000 all over d. And now we're going to look to minimize this, which means we're going to set this equal to 0, and then we multiply through by the d. Now that's why I didn't do this in terms of a square root, because I knew that d was going to disappear anyway. And so now to solve for t, okay, sorry, I should do this first here. So it's going to be 10,000t minus 6,000 is equal to 0. And if you solve for t here, you get that t is equal to 3/5. So in other words, in 3/5 of an hour, the distance between these two vehicles will be a minimum. Now, it doesn't take much here to realize that that's 36 minutes. Okay, but the question wasn't asking for that. The question was asking, what is the minimum distance? Well, the min distance is going to require you, okay, whoops, sorry about that, is going to require you to substitute that back in. So d is going to equal the square root of 80 times 3/5 all squared plus in brackets 100 minus 60 times 3/5, and that is all squared. And after just a little bit of work here, we see that 80 divided by 5, 12 times 3. Okay, anyway, it works out here really quickly that this all becomes 80. I just did that on my calculator a little while ago, and we get the minimum distance here is 80 kilometers.